Hi guys, welcome back to the vlogs.
Okay, let's talk about 7.2, similar triangles. So yesterday we talked about angle, angle, yes? And we talked about side, side, side similarity, those two. Okay, so angle, angle similarity is saying, hey, two triangles are similar if two of their angles are congruent. Side, side, side similarity says two triangles are similar if their sides, all three sides, become equivalent proportions. Okay? Side angle side says if I have a side that is proportional to another side of a triangle with an angle in between them that are equal, then they are similar. So side angle side. If the lengths of two corresponding sides of two triangles are proportional and the angles the sides form are congruent, then the triangles are similar. So it's just like the same thing. Remember, when we do side, angle, side, we go in order. Side, angle, side. It's like a sandwich. So you have side, angle, side similarity theorem now. So for congruency theorems, what do we have?
It's the lengths of the
Side, side, side. Hypotenuse, length. Side, angle, side. Angle, side, angle. What else? And one more. You said angle, side, 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 angle, side, hypotenuse, length, and
angle and side.
angle, side. For similarity, what are the three that we've talked about now?
Side angle side.
Angle, and side, side. And what's the difference between congruency and similarity? Okay, yes, so in similarity, the angles are the same, the lengths are different, but they're proportional. In congruency, everything is equal, okay? Everything is equal. Okay. This only has 3 slides today, pretty simple. Now, it wants us to prove that triangle ABC is similar to triangle ADE. Okay? ABC and ADE. Now for me, this is just how I work. I separate those two triangles and redraw them so that I can see things, so that I don't get confused. You can do that, or you don't have to do that. I think it's easier if we do that. So if I redraw these and I make triangle ABC, that's the large triangle, right? Any place, I'm gonna do it this way. So ABC. So the side length of C is 9 plus 3, so it's 12, right? This side length we don't know, and this side length we know is 8. If I redraw the little triangle AED, and remember, it doesn't have to be accurate, I just draw it so that I can think. Okay, I know that I don't know what this side is. I know this is 9, and I know this is 6, okay? So it wants us to prove that these are congruent, okay? Or that they're similar. Well, I can automatically state, for the first reason, remember we did reasons, or statements and reasons, okay, it's already written out there. I can already state that angle A is congruent to angle A. Why do I know that? What? Right. Word that in how I want it though. Reflexive. Reflexive. So they're the same angle, so reflexive. Now, If I'm doing similarity, that means that I have to have proportions, yes? So the next step would probably be to say, AE over AC equals AD over AB, right? And then I would want to substitute those numbers in, okay? So I'm setting up a proportion. From there, I'm going to plug the numbers in, right? So 9 over 12 equals 6 over 8, which would reduce to what? What do those reduce to? What do those fractions reduce to? Yeah, 3/4. Okay, they reduced to 3/4. So all we did was substitution. And we simplified it. Okay, so now we have that, okay? So now that I know that, I can say triangle ABC is similar to triangle AED. Because of side angle, side similarity. I need you to make sure that you write side angle, side similarity. If you don't write similarity with it, I don't know that you want them to be similar. Because side angle, side is for congruency, if you just leave it by itself. So that is how you would make a proof for that. Does that make sense? Okay, there are other ways you can do it. The book does it longer in different ways. Okay, it depends what you look at and what you do. Okay. Last part. Okay. A person who is 2 meters tall looks into a mirror that has been placed on the ground 3 meters away and sees the reflection of the top of a telephone pole. If the distance between the telephone pole and the mirror is 21 meters, how tall is the telephone pole? Okay. So, a person is 2 meters tall, right? So here's my person, they're 2 meters. How far away are they from the mirror? 3 meters.
Oh, I was looking at that one. Yeah, okay.
Okay, they're 3 meters away from this mirror, right? And they're looking down on it basically, right? Okay. From that mirror, okay, they see a reflection of the top of a telephone pole. Okay? But the telephone pole is how far away? Okay, so if this is where the mirror is, it's 21 meters from there. Okay, and they're looking like this into this reflection. So they're trying to figure out how tall this part is. How can I figure that out?
2 over 3 and 21 over
What?
32 over x equals to that one.
Okay, 2 over x equals 3 over 21. Okay, we can set it up that way. 2 over x equals 3 over 21. When I do that, what do I get when I multiply 2 and 21 together?
42.
And what's 42 divided by 3?
14.
So x equals 14 meters, yes? 14 meters tall. Beautiful. This is what your homework's over tonight. I think it's pretty simple.
I'll
Okay?
set the vlog.
Yeah, go ahead.
I'm curious. Like, subscribe, comment, tweet me at David Dobrik. Anything else to add, Korea?
Nope.
Bye.